All right, here is a geometry problem. Length of a rectangle is 3 inches less than twice its width. If the perimeter of the rectangle is 84, find the dimensions of the rectangle. All right, this feels like it calls for a picture. Geometry, we always like to draw pictures. And so rectangle looks like that. It makes reference to a length and a width. Let's call this one the length, and we'll call that one the width. We want the dimensions, so that's what we're trying to find. We're trying to find the width of the rectangle, the length of the rectangle. So in this picture, I've defined what I'm trying to find. It says that the length of the rectangle is, okay, so L is 3 less than twice the width. So if I get twice the width, I want to go 3 smaller than that, 3 less than twice the width. That's a relationship that it's giving me between the length and the width. Now it says the perimeter of the rectangle is 84. Well, perimeter, I'm going to need 2 L's and 2 W's to get all the way around that triangle. So my other equation is going to look like 2L plus 2W, and that is supposed to be 84 inches. Well, it's very clearly set up to do a substitution here already. So that's 2 times 2W's minus 3 plus 2W's is equal to 84. If I distribute here, we get 4W's minus 6 plus 2W's is 84. I can combine these. I get 4W's plus 2W's, that's 6W's. I still have a minus 6 there, is equal to 84. We add 6 to both sides. I get that 6W's are equal to 90. And if I divide by 6, I get that the width of this should be 15. So the one dimension of my rectangle is 15. And then I can come back up to this equation that said the length is 2 times whatever the width is, which I now know is 15, minus 3. So that's 30 minus 3, which is 27 for the length. Okay, so dimensions of my rectangle, it is a 15 by 27 rectangle. All right, let's go for a science problem. A chemist mixes a 10% acid solution with a 50% acid solution to form 400 milliliters of a 40% solution. How much of each solution should be used in the mixture? So how much of each? My two solutions were a 10% and a 50%. I'll let X be the milliliters of the 10% acid solution. That's an N. And Y will be the milliliters of the 50% acid solution. Okay, so now I look for the relationships that it tells me. It tells me I want 400 milliliters total, so that feels like an X plus Y equals 400. And I want it to be a 40% solution. Okay, so that means I want 40% of my final solution to be pure acid. In the 10% solution, 10% of that is pure acid, so my next equation, I want 10% of the number of milliliters that I use of the 10% solution will be pure acid. Okay, so this equation here is about total volume. And I'm going to make one equation here about how much acid that I have. So when I throw some of the 50% solution in, half of that, or 50% times the number of milliliters of that I use will be pure acid. And in the end, I want, of my 400 milliliters, I could probably do that in the other order here, I want to have 40% of my 400 milliliters be pure acid in the end. Okay, so I can go through here, I could multiply, I could shift decimal point one place in all of these problems, and that would tell me that I have an x plus 5y is 4 times 400, which is, when I shift that decimal point one place there, it becomes a 4 times 400 is 1600. Well, if I bring this equation back down, but I multiply it by -1 first, we'll do this one. We haven't done one with elimination yet. I'm going to change the signs on all of those. So I have a -x minus y is -400. I'm anticipating a lot more of the y, right? The 50%, because I want to end up with 40%. So I'm just diluting it a little bit with the other stuff. All right, so x minus x, that's no x's. 5y's minus 1y is 4y's. And 1600 minus 400 is 1200. And if we then divide by 4, we get 300 milliliters of the 50% solution. And if the two were supposed to add up to 400, then that must be 100 milliliters of the 10% acid solution. Okay. So that's how that one looks. All right, I'm going to see if I can get this motion problem done in the space that I have down here, and still keep this down to a reasonable amount of time. Jet flew east a distance of 1,800 miles with the jet stream in 3 hours. Returning west against the jet stream, it took 4 hours. Find the jet's speed in still air and the rate of the jet stream. So let's I'm going to define J to be the speed of the jet, probably in miles per hour. And W, jet stream, is a wind, so I'm going to use W for the wind. Speed of the jet stream, which would also be in miles per hour. Okay, it's going to make use of the rate times time equals distance formula. That's something we should always keep in mind. So the rates are the things that I'm trying to find. It says on the eastern trip, so let's make one equation for when the jet was heading east. When it was heading east, the wind was blowing at its back, so that was adding to the speed of the jet. So the speed of the jet was assisted by the speed of the wind. That's the rate flying east, times the time, which was 3 hours. It traveled 1,800 miles. Okay. So these were in miles per hour times hours will cancel to give us units of miles. Now when we turn around and we have to come back to the west, we have the speed of the jet, but we have to fly against the wind, so the wind takes away from the speed that the jet can fly. So that's its rate when it's on its westward flight. That took 4 hours to cover the same 1,800 miles. Okay. Fortunately, 1,800 is divisible by both of these, so I'm going to change this equation. I'm going to divide by 3 on both sides. That will give me J plus W is equal to 600. And if we divide both sides of this by 400, we get that J minus W is equal to 450. And that is set up very nicely to just add those together and get 2 times the speed of the jet is 1,050. Dividing by 2, the speed of the jet must be 525 miles per hour. And we know that the jet plus the wind is 600. If the jet was 525, then that must mean that the wind was 75 miles an hour. Okay, so the jet 525, and we know that J, which is 525, plus W is equal to 600. So subtract 525 from both sides, and the wind must have been 75 miles an hour in the jet stream.